All right. Section 1.5, function operations. In a function, let's see, how do I... Let's say, so we want to be able to, there are a few things we want to be able to do, like just like how we can take, when you were in, let me have a little story time with Mr. Mitchell. When you were in like 3rd grade and you learned how to add numbers and subtract numbers, and you moved to 4th grade, you multiplied, and then you did some long division, right? You were doing these operations, adding, subtracting, multiplying, dividing with numbers. In math, we want to be able to do these operations to things that are like to other kinds of things, right? So we want to be able to we want to be able to add, subtract, multiply. Why is this multiply, and divide functions. So we want to take a whole equation and add it to another equation, or a whole equation subtract it from another equation. So we're going to do this to a couple functions. We're going to try, I'm going to show you what this looks like and how to do these operations. So let's say, for example, let's say we have two functions. Let's say we have f of x, and let's say f of x is equal to 2x minus 5. And let's say we have g of x, and let's say g of x is x squared plus 7x minus 8. We have these two functions. And we're going to perform these mathematical operations adding, subtracting, multiplying, dividing on equations. So what's this look like? Well, let's do some adding. To add, the way this is written down is you'll see it in a few ways. You could see it like this: f of x plus g of x. You can see it like that, right? Just f of x plus g of x straight up. Or you might also see it as just f plus g of x. You might see it like that. These two things mean the same thing. This x here means not multiply. This is the input of the functions. And I want to put a big star here, not multiply. Not multiply. Lots of stars. It is an input. It's just like these things. These things right here, not a multiplication, it's an input, right? That's what this is. They're the same thing. It's telling, I'm going to move this up. It's telling you what you are plugging in, what variable to use in the equation. It's telling you the variable to use, not a multiplication. Okay. So let's do this addition. And all you're doing is you're taking one equation. Let's take so it says f plus g. So here's my f equation. My f equation is 2x minus 5 plus, and you put your g equation, x squared plus 7x minus 8. Literally, you just put them together, f plus g. And then you combine. Add by, different color. What you do here is you would add by, you would just combine, or maybe I'll just say simplify. I'll just say simplify. Once you have this adding up together here, once you have this written down, you're just going to simplify. That means combine like terms, add these together. So I don't need these parentheses because I'm not distributing anything. They're adding together, so I'm going to erase those parentheses. And I'm just going to combine the like terms. So my x squared, this is by itself. So I got a 1x squared piece just by itself. My x squared. And then I got 2x and 7x. 2x plus 7x, that's going to be plus 9x. And then I got my minus 5 and minus 8. Negative 5 plus negative 8, that's negative 13. And there's your answer. Add those equations together. So you're just combining like terms. You're adding two functions. Okay. Let's try subtracting. Again, you're going to have things like written like this, g of x minus f of x. Or you'll have g minus f of x. So be careful about the order of the equations. This one says g of x minus f of x. So I need to do this in the correct order. I need to put my g of x first. That's going to be x squared plus 7x minus 8, 7. And then take that and minus my f of x equation, which was 2x minus 5. Literally just subtracting the two equations from each other. Now the thing you have to be careful about with subtraction is you need to remember to distribute the negative. Distribute the negative. Because it's a negative sign, it applies to all the pieces of your second function. It gets distributed to all the pieces of your second function. So, and this is just a reminder to be like aware, to be wary, to be on your guard when you have subtraction. Subtraction is always going to be a little, causes some tricks like this, cause trouble. Addition, no problem. Addition's easy. Everybody loves addition. Subtraction, you always got to be careful. Do I need to distribute that negative? Does it go to both things? Yeah, make sure you're careful about it. So this is going to equal x squared plus 7x minus 8 minus 2x plus 5. Minus times a minus means plus 5 here. Okay? And then combine the like terms. I get x squared. 7x minus 2x, that's going to be plus 5x. And then negative 8 plus 5, that's going to be negative 3. And that's my equation for subtraction. I made a new function subtracting two other functions, combining them together. Okay. Nothing crazy. Is that 7x? Yeah, that's the 7x. Yeah, this right here. Yeah, I don't know why my pen is being so sensitive today. Plus 7x minus 8. It's just one minus there. I don't know why there's like little marks. Get it together, pen. Plus all right. Let's do next. Let's multiply. So we're going to take, again, multiplication is, you see it like f of x times g of x. You see them written next to each other. Sometimes there's a dot between them. Sometimes there isn't. You can also just say f times g with a dot. Multiply. All right, so multiplying f times g. Again, I'm going to just put my equations in parentheses. F is 2x minus 5. And g is x squared plus 7x minus 8. And I am simply going to distribute. Multiply, multiply, multiply. With multiplication, you need to distribute. Oh, God. Distribute. We're multiplying these together, combining like terms. When you multiply, remember your exponents change. So 2x times x squared, that's going to be 2x cubed. Because I had 1x from here and 2x's from here, and they combine together to x cubed. Right, multiplication makes them cubed. 2x times 7x, that's going to be plus 14x. 14x. And then 2x times negative 8, that's going to be negative 16x. Oh, sorry, x squared. X squared. 14x squared. X times x, right? 17 times 4. 17 times 2. X times x squared. And then I distribute the 5. The negative, so that's all the 2x's. I then distribute the negative 5 to all the pieces. Negative 5 times that, negative 5 times that, negative 5 times that. Negative 5 times 2 times x squared is negative 5 x squared. Negative 5 times 7x is negative 35x. And the negative 5 times negative 8 is positive 40. Right? Multiplying our things together, doing distribution. Then we go through, pardon everybody, then we go through and combine the like terms. So we got 2x cubed, there's only one of those. 2x cubed. So that one, ooh, not 8. Stop it there. Cubed. One of those, right? And then there's an x squared and an x squared. So 14 minus 5, that's going to be plus 9x squared. Combine like terms. And then there's the x piece, and there's the x piece. Negative 16 minus 35, that's going to be negative, ooh, let's see, 51x. Yeah? 3 plus 1 is 4. 5 plus 6 is 11. 4 plus 1 is 5, 51. And then our 40 is all by itself. And there we go. Easy, right? No problem. Adding, subtracting, multiplying, and dividing. Right? Straightforward. Let's try the last one. Divide. Good. Divide. So for division, you'll see that same thing. You'll see it like this with f of x over g of x, like that. Or sometimes it's just f over g, like that. Same things, same things. So for division, what you have is you just write the equation like a fraction. Put your f part on top, put your g part on the bottom. So my f equation was 2x minus 5. My g equation was x squared plus 7x minus 8. Right? And can I simplify this at all? Anything to combine here? Is there any kind of like factoring I can do to simplify? Is there any kind of canceling I can do? Not with this one. So that's it. We're done. You thought division was going to be hard, didn't you? You thought division was going to be hard. It was the easiest one. Easiest one. Write it like a fraction. And you're done. However, there's one thing you need to remember with division. It's the easiest one, yes. There's like you just write it as a fraction. But what do we remember that we've done when we have variables on the bottom of an equation? What does that mean? What did we just do in the homework? Variables on the denominator. There's a problem with that. What gets affected? What gets restricted? We have variables on the denominator. Yeah, it can't be 0, right? So we have a domain restriction. When we do the division ones, automatically, we guarantee we have a domain restriction. So let me write this over here in red. We have a domain restriction. And we have to say it. We have to explain that we have a restriction. Domain restriction. When we have divisions, we have to explain, here's our new function f divided by g, but this new function has some numbers that are not allowed. So the restriction is this bottom part cannot be 0. And so I have a quadratic here. Whenever we have quadratics, we have to factor. And those two factors will tell us the restrictions. You have to factor it apart. So, 8, I can have 4 times 2, or 7 and 1. Oh, 8 and 1, I'm talking about 8 and 1. What are my factors going to be? There's too much space here. What are my factors? If you're not good with factoring, you got to really practice your factoring. Remember, you're taking this 8 number, and you're thinking of what numbers can multiply together to make 8. I can have 4 times 2, and I can have 8 times 1. But you want to add together to make 7. So 4 and 2, 4, 5, 6, that makes 6, not 7. But 8 and 1, I have to have positive 7, so I need to have a positive 8 and a negative 1. And those become my factors. X plus 8 and x minus 1. So what is my domain restrictions? What is x not allowed to be? 8 and negative 1? Is that right? Those are the numbers I got. Yeah? 8 and negative 1? Is that my restriction? Flip the negative. Thank you, Edward. Yes, this becomes a negative 8 and a positive 1, right? We have to change the signs. That is my domain restriction. Cannot be negative 8 and it cannot be positive 1. Ugly numbers here. X cannot equal negative 8 and positive 1. So switch the signs, right? So every division has this domain restriction situation. So you got to figure out what is your domain restriction. Tell me the domain restrictions. And anytime you have a fraction with these equations, you have that domain restriction. All right? Problems, worries, concerns, questions? Adding, subtracting, multiplying, dividing functions. Pretty straightforward, right? Combine the like terms, simple stuff like that. Now let's use it. Using, oh, not red. Using function operations. Function operations. So what do we do with these? Well, we have equations. I can move this, right? Everyone got that? Yell at me if you need me to show you something. We're going to use these, and we use these in equations. We do this with things like, we see things like this. Let me give you two functions. Let's say that h of x is equal to, I don't know, let's say x squared plus 2. And let's say, I don't know, what's a good function name? R of x, whatever. Let's call it, let's call this one 1 over x. Two functions, a little more complicated than before. X squared plus 2 and 1 over x. So how would I combine together? Let's add these. Let's do h plus r of x. How do I add these? Well, function addition, you just write them out, adding them together. X squared plus 2 plus 1 over x. Right? X squared plus 2 plus 1 over x. Looking at this, is there any way I can simplify this? Can I do something to combine all these together? Well, I have a fraction, 1 over x. And so if I want to add fractions, I got to make these other things fractions. And I got to give them an x on the bottom and the top and make it all messy. We can, right? I can give this, put an x down here, multiply that by x, give this 2 an x on the top and the bottom, put them all together, right? You can. But I'm going to say, for our purposes, this is fine. That's fine. I don't want to get you too annoyed by combining crazy equations. If the equation's too crazy, just leave it. Just leave it. Totally fine. Right? Not a problem. Okay. What about if I wanted to do h times r of x? What if I multiplied part b? H times r, multiply. Okay. H times r, well, my h is, I multiply, just put x squared plus 2 times 1 over x. A little more complicated equation. A little more to think about when combining these. Can I multiply these equations? So for addition, you can leave it alone. But for multiplication, can I do something here? Multiplication is much easier. Multiplication is much more friendly. I can multiply these together. This part here, if I make this a fraction over 1, the multiplication of these two things, well, the top parts multiply, x squared plus 2, that's x squared plus, this is black. I get x squared plus 2 on the top, and on the bottom, I get x. And that's my answer here. And that's fine. So I do want you for multiplication, I want you to go as far as you can. I want you to do as much as you can to simplify, to explain, right? What about if I did h over r? H over r, what is that? So put my functions together. H is x squared plus 2 divided by 1 over x. So for multiplication, I wanted you to do the multiplication. Same thing for division, I want you to simplify. How can I make this fraction over, this is an ugly fraction over fraction, what do I do with this situation? And what I do, take the bottom fraction to get rid of it, do a little, what did I say, flip-a-do, a little flip-a-do, flip and multiply. And multiply. Keep, change, flip, or whatever that's called. So you have x squared you've got x squared minus plus 2 times 1 over x flipped is just going to be x, or x over 1, but really it's just x. We don't write the over 1, we don't need that part. It's just x. I can multiply those, no problem. Distribute that x to both of these things, I get x cubed plus 2x. There's your division, which becomes a multiplication. So when you have a fraction over fraction, fraction on the bottom right, there's all these rules, all these manipulations that you are going to have to become comfortable with. Manipulating these equations, you will have to become comfortable navigating this algebraic world. You have been doing this for a long time now. Pre-calculus, you do it. All right. Last part. Plugging in. Last thing you will be asked to do is to plug in to these combined equations. So let's say, for example, I have a function f that is, let's call it 3x plus 2, and g of x is x squared minus 1. Okay, two functions. You might see something like, part A, you might see something like f plus g of 4. You might see something like this. What this means, the 4 here means you're going to plug in 4 for x. This means you add the equations, just like regular, but everywhere you see an x in the equations, you plug in the 4. You add them like regular, but this 4 means you plug the 4 into the x. That's what this means. This 4 is not a multiply. It means you're plugging it in. Right? Take the 4, and it gets plugged in. Plugged into g, plugged into f. Plug in. So we're going to get f is 3, and then instead of x, we're going to write 4, because we're plugging in 4, plus 2, plus x squared. Instead of x, we're going to write 4 squared minus 1. Let me do this. Let me do this a different way. So right now we have x's. Right now we have x's, but the equation is plugging in the 4's. So you write the equation like regular. You can think of it like that, and then plug in the 4's. So you're plugging in 4 into your equation. I'm doing this in 2 steps. You don't need to do this 2 steps. I just want to show you explicitly what you're doing, right? The x's are there, but then you plug in the 4 into the equation, into x. So then you just calculate. You're going to get a number for an answer here. Since you're plugging in, you're going to get a value. So what is this going to be? 3 times 4 is 12. 12 plus 2 plus 4 squared is 16 minus 1. So 12 plus 2 is 14 plus 16 minus 1. 14 plus 16 is 30 minus 1 is 29. Oh man, that's real ugly. Why are you being so ugly, pen? Why are you being so ugly? 16, 12 plus 2. Everyone see that? Is that okay, everybody? Hopefully it's not too messy. Okay. You're plugging in. When you do this plugging in, you get a number. You get a number for an answer. Let's try this again. Let's do f over g of negative 1. F over g of negative 1. So put the f on the top, 3x plus 2. G on the bottom, x squared minus 1. And then plug in my negative 1. So I'm going to have 3 times negative 1 plus 2 over negative 1 squared minus 1. Goodness gracious. 3 times negative 1 is, wait, there's a 2, right? There's a 2 here. God. This is a 2 here, everybody. And 3 times negative 1 is negative 3 plus 2 is going to be negative 1 on the top. Negative 1 squared is 1. 1 minus 1 is 0 on the bottom. Uh-oh. Uh-oh. Oh no. Oh god. What do I do? The 0 on the bottom. That was not allowed. I'm breaking the rules. What do we do here? Is that allowed? I can't divide by 0. No. We cannot. We are not allowed to divide by 0. Plug it in a calculator. You'll see, if you try it in a calculator, your answer will be error. If we try plugging negative 1 divided by 0 in the calculator to get a number, the answer will be an error. And the reason why is we're not allowed to divide by 0. And so what do we write? If we get an answer with a 0 on the bottom, how do we explain that answer? The words we use, we're going to use a word, we're going to say this is undefined. Undefined. And literally that word is what you use in the answer. Undefined. If you ever have a situation where you divide by 0, your answer is undefined. Because we're not allowed to divide by 0. So negative 1 gives us no response. All right. We are out of time. I just wanted to show you those last ones. Situations are going to come up, but make sure you get them. You have a homework assignment. The next time I see you is going to be Wednesday, so we got some time. Your homework. Section 1.5, numbers 1 through 4 all, and I'll put this all on Schoology. 5 through 25 odd. And that's it. That's your homework. 1 to 4 all, 5 to 25 odd. Some other weird situations are going to arise. Try them out. Now you have the work you can check. Yes, once you are written down, you can feel free to say goodbye in the chat. Once you say goodbye, you're free to go. Thank you all. Oh, what page? What page? Thank you, thank you. Page 58. Page 58. Page 58. I'll put that up on Schoology. Thank you, everybody. Good job today. Lots to do. Have a great weekend. See you all next time.